Okay, good morning everybody. My name is Freddy Paya. I work for the company PCI Geomatics, and I'd like to thank everybody here today for attending this presentation. Of course, the honorary consul, Ricardo and Franz, for the invitation. Today we're going to talk, I got the mic here. Today we're going to talk about our technology of PCI Geomatics related to emergency response. Everybody knows the disaster that happened in Brumadinho a few months ago, and the reason why we're here is because we want to collaborate and we want to help in any way possible to the monitor of the disaster, but also in future events, in any catastrophic events. We want to show what we can do with our technology for that. Just to tell you a little bit more about our company is PCI Geomatics. We are a Canadian company. Besides creating technology, developing software, we also like to support other countries, and we like to support other governments. In the past experiences, for example, we've helped the Ecuadorian government after the earthquake through the Canadian Embassy. Also in Guatemala, we helped with the volcano disaster that happened there. So in this case, we're here trying to support in any way possible, as I said before, with the disaster that happened in Brumadinho. But just to tell you a little bit more about our company, we've been around for 37 years. We are a private company that has presence in over 130 countries. And what we do is develop technology. We create software. We work with the government of Canada as well, developing technology. And our software is mainly used for, of course, using geospatial data. So any information that is captured by a sensor, can be a satellite, can be a drone, can be an aerial camera. We have tools and algorithms to process that data, and also to create information, extract information, and do analytics.
Wait a minute.
Sure.
We are bringing a microphone.
I got one. Oh, you want me to get another one? Okay.
Are you taking it?
I got this one.
Okay. We can share this We can share this. The registration.
Sure. Is this one okay?
Yeah.
Yeah. Okay.
Yeah. We just need it to match with the presentation.
Yeah.
Oh.
The microphone to record your.
To do the editing.
Yeah.
The class.
So we're gonna get another microphone.
Yeah, but it's just for registration, just for recording.
Okay.
But you have one.
I have one.
This is good enough.
Okay, perfect. Okay.
This is good enough.
Should we continue?
We continue.
Okay.
Because we will be editing the data.
Yeah. Okay, perfect. Okay, the slogan of our company is get more from imagery. And the reason why we chose that slogan is because anybody can get an image or some sort of picture like the one you can see on the screen, and what we do is we create tools for you to extract information from that image. So for example, here we are monitoring the crops. We're doing something called precision agriculture. As well, we have a mine on the top of the image, and we can create elevation models from that. We have a forest also in the image, and we can detect any deforestation, illegal deforestation, or changes in the forest. As well, we have an urban area, and what we can do is we create cities in 3D, or we can also extract classes from that city. And finally, in the ocean, we can detect ships. So some things that you can do from one image. We work in a variety of different applications in different sectors. You can see some of them here. Our technology has a variety of different tools to work in all of these different sectors. Just to give you a quick summary of some of the examples that we can work in every sector. For example, in the environment vertical market, you can do things like monitoring illegal deforestation in a forest. You can also estimate the biomass from a forest, and you can look at wildfires in a forest. So some of the things you can do with our technology in that specific sector. The crops are, if they're healthy, if they're okay, or if they need some chemicals, or if they need something else. As well, you can predict the yield, how the crops are doing, and when you're going to be able to go and get the crops. Some of the things that you can do as well. In mining, you can do interferometry, so basically look at map deformation and see if there's subsidence in your terrain. You can also calculate volumes and look at the productivity in your mine. And of course, in the exploration part, you can do a spectral analysis. So basically, you're looking for coefficients of high minerals or low minerals. In the sector of petroleum and gas, oil and gas, you can do a lot of things. For example, exploration. You can do take a look at lineaments and see where you know, for example, gas or oil may be in the terrain. Also, you can look at spills on the ocean. So those are some of the kind of things you can do as well with our technology. In the urban and topographic sector, you can create, as I said before, elevation models. You can see how the terrain is in your city, in your area of interest. You can do automatic cartography. So basically, you're going to be extracting different classes from your city or from your area of interest. So and finally is another sector where we heavily are involved in is the defense and intelligence. So we work with a lot of institutions here in Latin America and other parts of the world. For example, monitoring illicit crops. So one of a big issue here in Latin America. So we work with a lot of police anti-narcotics groups, trying to help them to identify what the crops are. Ship detection in the ocean, also something problematic here in the oceans. We have a lot of illegal ships and a lot of you know, different kind of ships, so detect those ships. And of course, change detection with targets. Okay, so that's a little bit of a summary of what we offer and what we do. The main part of the presentation will be how can we use our technology to prevent and mitigate disasters. So we had a disaster here in Brazil. It was catastrophic. And an important thing to do and to learn from that is to be prepared for future events. And how can we be prepared for that? We can use, of course, imagery that is collected by satellites, by drones, by aerial cameras, to have that information available and ready to, of course, be prepared for any catastrophic event. So that's a picture of Brumadinho. Of course, you guys are aware of that. You told me that you were there afterwards, and it was extremely sad and painful to see what happened. And you know, perhaps people were not prepared, people were not monitoring the dam, so that's very, very sad to see. One thing that I wanted to tell you about, perhaps you don't know much about it, but there's an international charter of space and major disasters. So basically, when there is a disaster around the world, this organization provides for free satellite data to that country. So for example, in Bolivia, a few months ago, if I remember correctly, there was a lot of rain, there was some flooding. So all the countries that are organized in this charter group, they give data. So Canada has a radar satellite, it's called RadarSat-2. So if anything happens, Canada will be providing for free imagery to that specific country. Another example that I can tell you about is, you might remember the submarine that went missing in Argentina 2 years ago. Of course, that went on in the international charter space of major disasters. Italy, for example, they provided imagery in other countries in the world, and I can tell you a little bit more about that because we were involved as well in helping the Argentinian government, more specifically the army, to be able to help for them to find the submarine. These are some of the imagery from the dam collapse here in Brumadinho. You can see, you know, of course, you know the area better than I do, so you can see where the dam is and what happened afterwards. So what we're doing here is we're doing change detection. We're looking before the event and after the event. We're going to be quantifying damages. We're going to be looking at the roads. We're going to be looking where people can be. So it's very important to be part of this charter and this organization because we can obtain data for free, and that can facilitate our emergency response groups to be able to go to the location and to be able to find what's happening and help with the disaster. One example, just to go into applications and talk about examples, one of the things we can do is we can do ship detection. So basically using radar imagery, which is imagery that penetrates the clouds and can be taken overnight, we can find ships on the oceans or objects on the terrain, on the land. So I said before, I was in Argentina 2 years ago. I met with the colonel from the army. We continued, we kept in touch. He called me on a Saturday in December, that was early December. He said, Freddy, one of our submarines went missing. We need some help. We need to be able to locate that submarine. There's 44 people in the submarine. How can you help us? So as I said before, they got a lot of imagery from Italy, from Cosmos SkyMed, which is a satellite. They sent us all that data, and our scientists were working hard to be able to find that submarine. These are some of the imagery that we got. We found some objects, as you can see on the screens. The submarine never went to the top of the water, to the surface of the water, so we never found anything. And unfortunately, as you saw, a year later, they found the submarine, but you know, they will not be able to detect it on time. Something else that we help as well here in Latin America is to be able to monitor illicit crops. As I said before, in countries like Colombia and Peru, there's police anti-narcotics and groups that are looking for illicit crops using satellite data. And that's something where we collaborate as well. This is an image of, in Colombia, some area where they're growing illicit crops. You can see the detection of those crops, and that's something where you can also be prepared as a country, as a military group, to be able to locate those areas. Okay, so that's a little bit of disaster management and how can we be prepared for any catastrophic event. So I want to emphasize, and the message that I want to get across today is how critical and how important it is to use imagery from satellites, from drones, from cameras, to be able to monitor our terrains, our area of interest, and prevent any catastrophic events. So I talked about you know, all these satellites that are going around the world. I talked about the charter group that some countries are part of, and they offer imagery so governments can quantify damages and of course monitor areas. So one of the things that we can do to be prepared for any events or disasters is using interferometry. So that's one of our tools or one of our technologies that we have, where what we're doing right now is using satellite data, we can monitor any deformation on the terrain. So we can look at subsidence or elevation on the terrain. So here, for example, what they're doing here is they're injecting gas in the reservoir, and that can cause dilatation on the surface. So of course there's going to be some movement on the terrain, and what we can do is a variety of things, but this is important, for example, for underground mining, for illegal mining, for infrastructure monitoring, for mine bank monitoring, acid mine drainage. So there's a lot of things that you can do, and all of these causes can of course impact the terrain, and that can cause a disaster. So that's why it's critical to be able to maintain a constant monitoring on areas like this. So this is a mine in Canada, and what they're doing is they're injecting gas in the terrain. So you can see, I'm going to explain a little bit here what's happening. So this is the terrain. So you know, this color is showing there's no changes on the terrain. If it's blue, if you see a blue, it's because there's subsidence, meaning there's the floor or the ground is going down, there's deformation. And if you see purple, orange is going up. They're injecting a gas in the subsurface and it's going up. So what we're doing is monitoring using different images over a time lapse, and we're going to be checking and see if there's any movement on the terrain. So one story to tell you, I was in Peru for a mining conference, Expo Mina, you might have been there before. I talked to a mining company, and they were not doing any monitoring on the terrain. So what happened is there was a deformation of the terrain. There was a truck driver going by. So an area collapsed over the truck. The person was killed. They had to stop the productivity in the mine. It cost them millions and millions of dollars. One person dead. So that's why it's critical for us to be constantly monitoring and constantly checking that there's no deformation in this case or anything happening, so we can avoid any disasters. So if you take a look at the screen here, we're injecting gas in the subsurface, and look how everything changes. So you can see the one before, you can see how everything's changing, and then finally we're gonna see there's a big change in this area. There's injecting gas, so of course the surface or the terrain is elevating. So that's one thing that we can do, for example. Another thing we can do is precision agriculture. So very important in the agricultural sector for farmers, for anybody that is interested in the crops, in the agriculture. We can use either satellite data, drone data to monitor how the vegetation is or how the crops are. So this is important for a lot of things. So for example, if you want to reduce material, by targeting the problem areas, if you want to save money, and if you want to save time, and of course optimize the crops. But more importantly, you don't want your crops to die. That can cause a lot of issues in the country if you have a big agricultural sector and they're not monitoring constantly your crops or your vegetation. So this is one of the things that you can do with our technology. You can extract different types of information. In this case, we're extracting chlorophyll in area of vegetation, and we're creating maps that have that information available for farmers. So they know what's happening with their crops, where do they have to go, what kind of things they need to do. So it's very important for some countries that rely heavily on agriculture. Another example that I want to talk about in another set of applications is the use of imagery to respond to a disaster. So for example, the catastrophic event that happened in Brumadinho, what do we do now? How can we help? What do we need to do? So there's a lot of things that we can do about that. So one of the many issues that we have around the world is the forest fires. Happens everywhere in Australia and Canada and the US. Here in Brazil, I'm sure it's a big issue as well. And the exercise of actively searching for forest fires, but also continuously monitoring the previous ones is a critical job that all governments have to do. So we know how catastrophic forest fires can be. They're natural or man-made disasters that displaces people, destroys the flora, the fauna, and of course cost billions and billions of dollars. We can easily monitor the forest fires by using satellite data. So we're looking here some active fires, some burn scars, and we can of course quickly scan for these kinds of areas of interest, so we can provide that information to emergency responders for them to have a chance to put away the fires. As well, we can provide firefighters with the updated location and awareness of where the fires are. And one of the things you can do as well is to map and analyze burn scars. See what areas have been burned and what areas are affected by the fire. So that's something else that you can do with our technology. You can get the imagery, use a lot of tools and information to say, hey, these are the number of fires that we found in that forest. These are the area that that was burned. So that kind of information is important, as I said before, to give emergency response teams the information where the fires are, but also critical to prevent any fires, to constantly monitor active fires so it doesn't happen again. So just one quick example of that. Big issue in Brazil, forest monitoring, what's happening. There's a lot of illegal logging companies doing illegal deforestation in the Amazon. And it's important, of course, monitor the forest because it's the process of measuring and modeling and quantifying the change of carbon stock in the world. So, there's a lot of reasons why we need to monitor the forest. These are some of the applications why we need to monitor the forest. 3 of them: identify illegal logging, I guess one of the main issues here in Brazil. Of course, measure the loss or growth of forest area, and measure the forest biomass. So these are some of the applications you can do as well with our technology to monitor the forest. What we're looking at here is a forest that's in Canada, and there was a lot of deforestation throughout a time lapse, throughout a time frame. And we can quickly do a change detection. We can say this is the image from 2000, this is the image from 2019, and this is how the forest has changed over the past 9 years. So for example, we can have here, this is the total length of the image. We have 14,000 kilometers square, that's the image, and we have 641 kilometers square of the area of that image that has been deforested, in this case from 2000 to 2011. So something else that we can do as well with imagery and the tools, here in Brazil, of course, we have a big country, we have a big Amazon forest, and that's another example of an area of application that can be important for the government entities here. Oil spill. I know there's a lot of offshore exploration and exploitation of oil here in Brazil. We work with some entities in Brazil to be able to monitor the environmental impacts of offshore oil. And one of the things you can do as well is to be able to detect oil spills with satellite data. So what we're looking at here is an oil spill or a wind slick that happens in the ocean. And that can also be detected through satellite data. So we take an image of the ocean, we can take a look at it, and we can see this is the plant oil, this is the emulsion, and that's the crude oil. So we can detect and map where are the areas where the oil or the spill is. So you can use something called pulsar, which is a technology that can be used to use 4 polarizations of satellite data and to detect, in this case, oil spill. So that's something that we can do in order to respond to a disaster that happened in the ocean. This is another image of an oil spill, and something that we can do as well is we can detect the thickness of the oil. So it's important for the environmental groups that are going to go to respond to that emergency to see how thick or how thin the oil is. Something else that you can do with satellite data, and I'm going on and on talking about different applications, so you can have an idea. I want you to have an idea of what kind of things you can do, because in this industry, in geomatics, earth observation, whatever you want to call it, there's a lot of different things you can do. I've talked about agriculture, I've talked about defense and intelligence, now I'm talking about floods. So very important. I've heard that it's been raining a lot in Belo Horizonte, perhaps some areas are flooded right now. So another example that I want to tell you about is how we can use imagery to detect flooding or flood areas in a specific city. So for example, here we have, this is in Canada, this is close to Winnipeg if I'm not mistaken, and it rains a lot, I think a couple of years ago, 5 years ago or something, and a lot of the area of the city was flooded. So what we can do is we can, of course, have an image beforehand and afterwards and detect any changes. It's important because some roads perhaps were closed because of the floods. We can also see if there's any houses that were impacted by the flooding. So there's a lot of things that you can do. And here we're looking at the area that was flooded in this city, so the purple area here. And of course, what we can do afterwards is we can create maps to show the government or insurance companies or whatever group is interested in these kinds of information, what happened. So for example, that flood that occurred in 2005, here's the map from the government of Canada that created afterwards, after the event. And here we have the map that we created. So, something else that we can do, it's a big issue, I know, in Brazil as well, the floods in other parts of the world. So we can, of course, respond to any emergency that involves big rains and flooding. So that's a bit of a background on the applications and the kinds of things you can do. What I'm going to talk to you about is our technology, but I want to focus on something critical. So right now, because of what's happening in the industry, there's a trajectory of increasing of satellites and sensors. So just to give you an idea, in 1970, about 40, almost 50 years ago, there were only 2 countries with their own satellites. Only Russia and the US had their own satellites in 1970. Right now, we have a lot of countries with their satellites here in the region. Brazil has satellites, Peru has a satellite, Colombia recently launched a nano-satellite. So there's a lot of satellites in space, which means we have a lot of data. We have this term called big data. And it is critical to be prepared for that because, for example, what happened in Brumadinho, we have all these satellites going around the world, going around the planet, taking images, but we need to be able to respond to that emergency fast enough. We can have 1 million satellites, but if we don't have technology that can create results in a fast manner, we're not going to be able to, of course, be prepared to respond to any kind of disaster. So that's what we have been focusing on for the past years, to create technology that is robust, that is automatic, and that can be fast for any government or any institution to process that imagery and be able to have information to have it ready and available for emergency response groups. So that's something that we can talk about, and I can tell you a few examples. So we have systems, for example, that focus on automation to create information very fast from a lot of data, but we also have technology for users that are interested in research, in information extraction, and focusing on a specific area individually. So all of this technology that we've been creating for 37 years now is automatic, as I said before, and what we have done is to put it out there in a library in Python for anybody in the world to be able to create workflows. So for example, the government of Minas Gerais, they want to create a personalized automatic tool to be able to detect any collapses or any like dam collapse or any flooding or whatever you want to do in an automatic way. You can do it because we have put all these algorithms and all these tools in Python or any language that you want to do to be able to create your own workflow. So we have in this pyramid, if you take a look at it, we have this is all our science and our technology, almost 600 different algorithms. We've put everything in an API in Python. You guys are the expert knowledge in a specific field. You can be an expert in forestry or in agriculture or whatever you're an expert in. You can integrate a third-party application, so you can have other software or your own algorithms. And what you're going to do is you're going to create a build solution. You're going to create your own specific personalized solution to address your problem. So for example here, what we want to do is we want to be able to monitor the forest fires in Minas Gerais. So we create a specific tool to be able to actively monitor and detect any forest fires. So just to give you a quick example, if we wanted to look at a mine and take a look at the productivity, meaning we're going to see how much minerals they are extracting every day. We can go through a process of getting the data, creating elevation models, so on and so forth. But with these tools, you can automatically create a script or a workflow that is going to do it in a very fast, just by one click. This is an example of one of our clients, and what they're looking at is they created a website. They have their own platform online where they're going to look at the productivity in an open pit mine. So you don't have to know about mining or remote sensing. I mean, you don't have to know about remote sensing. You don't have to know how to process an image. What you're going to do is you're going to access to this company's platform. You're going to say, this is my area of interest, which is the mine, and then you're going to get all the statistics and all the information about your mine. So that's something that we're trying to get the governments of different countries to do, to create platforms, to create tools of their own so they can facilitate the information extraction of their citizens. So for example, the government of Brazil or the government of Minas Gerais, they can have these kind of platforms so users can say, how are my crops doing in my field? Or how are the active fires doing in my forest? So it's very important to be able to not only keep that information to ourselves, but to diffuse that information to other sources, other people, other groups, etc. Another example quickly here is this is an agricultural example. What we want to do is to do precision agriculture, so we want to see how the crops are doing in my specific field. We can as well, get the imagery or fly a drone. We can download the data. We can process data, do atmospheric correction, all of these different things. But as I said before, and I want you to keep this in mind, how the technology and how the industry is moving to automation and creating these tools automatically, so we don't have to do all of that. So one single script, one click, you're going to get all the data from the satellite or from the platform, and you're going to get the results. Meaning, where is my vegetation areas in my field, and which of those areas are problematic? Which ones of those areas need chemicals, or they need people to go out in the field and check on the crops? So those kinds of things you can do with that technology. So that's why, and as I said before, we are focusing and we are directing ourselves to creating technology to process high volumes of data. This is critical for an emergency response because imagine what happened in Brumadinho. Imagine we have 1 or 10 terabytes of data, and it's going to take us 2 months to prepare that data and give it to the emergency response. By the time 2 months go by, a lot of people are going to be dead. We won't be able to quantify the damages quickly enough. So that's why in an hour or 2 hours or in a day, we can have that information ready and available to send it to the groups, to send it to the army, and whoever entity here is looking after those disasters. So here's a picture of Brumadinho. That's before the dam collapsed. This is after the collapse. So you can see the changes. You can see everything that happened. So imagine you get that image an hour later. So you know specifically what areas are the main areas where you need to go, where you need to send your army, where you need to send your groups, etc. There's another picture of Brumadinho and the direction that all the the dam took after it was collapsed. This is another example. This is the country of Mexico. They had a lot of images of Mexico. They have 25,000 images of Mexico, and they needed to create a map. They needed to create a mosaic of the whole country for doing a variety of things, for looking at the agriculture, for looking at the urban areas, etc. This took them 3 months only. With any other tool, it would take them months and months or years to be able to create a whole mosaic, a whole map of 1.8 million kilometer squares and 25,000 images. They did it only in 3 months with our technology. This is another example that we did. This is a project that we ran in Toronto. It's a big city, perhaps not as big as Sao Paulo, but it's a big city. We had 4,000 images of an airplane that we had access to, that they flew, this company flew the area. They took images of Toronto, 4,000 images. And what we did is with one laptop over a weekend, we were able to create the maps of Toronto and create the elevation model of Toronto. So imagine having that kind of technology to be able to create a map in 1 weekend of the whole city of Toronto, and of course provide that information to the entities that need that. Another example that Mexico wanted to do with their mosaic is to extract the coastlines. So they have about 2,000 kilometers of coastlines, and they needed to get that information fast, and they needed to get that information ready. So they use more algorithms from our technology to be able to extract the coastlines. So that's something else. I want you to just keep in mind that in this world we have a lot of data, we have a lot of satellites, but we need to have the tools to be able to process that data fast enough to get those kinds of results. Just to continue, talking more about the kind of results and the kind of quality that you can obtain with our technology. This is an elevation model. What we're doing here is we have images, and we're going to extract the elevation on the terrain. So important as well for military groups. They're having a campaign, a military campaign. They're going to a specific area. They want to see how the terrain is. Or for mining companies, or for catastrophe purposes. A lot of things you can do this that you were going to need these kind of elevation models. This is a view in 3D. So imagine you're a military group. You're going to the border of your country. You're going to a specific area. You want to see how the location is, what is the terrain like, and so on and so forth. We can, of course, extract that kind of information and explore the area before you go. Just another example here of another city in Austria, the kind of products that we can create, and that's just to conclude the presentation. And as I said before at the beginning of my talk, the reason why we're here is because we want to collaborate with the government of Minas Gerais through the Canadian consulate and through the Canadian embassy to help in any way possible to monitor the area, to provide our technology to the different entities and groups that are constantly monitoring and doing work related to the dam collapse. And as I said, this is something that we have passion in doing, and we thrive in doing, to be able to help governments. And I mentioned a few examples before, and so that's why we're here today. And to conclude my presentation, and the message that I want to get across is that we have a lot of satellites, we have a lot of data available nowadays, and this data can be for free, like the charter group that I talked about, or we can have our own drones and fly. But what we need is technology and tools to be able to process that data fast enough, to be able to extract information and use that information to prevent any disasters and to mitigate disasters after they happened. So that is the message that I want to get across. And once again, I thank you for your time and for your participation here today.
Good. Fred, thank you. Some questions. First, before we will come back to Brumadinho, my question is, how affordable is this tool for, like, in the agricultural side, someone to monitor? Let's suppose I have a farm, and I want to check my farm and follow what is going on with my crops. How affordable? How do the people pay to have access to this information. I understood that I have a site where I can create my tool using Python, okay, and get some type of data. Is that right? Okay. How we pay for this, and how affordable is it for someone, for a farmer?
Yeah, so we have different configurations of our technology, and we work both with the academia, with the government, and the private sector. Talking about the private sector, an agricultural company, we can also, what we can do is of course, we can install the licenses or the technology for them to do the monitoring, or something else that we've done in the past is we have other companies, so let's say Brazilian companies, they can create that specific workflow for the farmer, and then they can use our technology in the background, which is what we were showing in the mining example, that we just give our technology, the client itself is creating that platform, creating that API to give access to a lot of mining users to be able to monitor their mines. So talking about how affordable it is, you know, we have different routes that we can take, but we can work with whoever clients they need to be able to create those solutions for them. And here in Brazil, we have, you know, government clients, and we have institutions, academic institutions that use our technology. So yeah, so I mean, we're open to work with anybody.
I understood that, Eduardo, you are this kind of provider as an interface for the final client and PCI, right?
Yes.
Do you work with like the farmer side?
Yes, there are some clients interested in that. Not only to acquire the image, but processing the image too for agricultural purposes, vegetation indexes, things like
If
that.
you do have clients now doing this
Yes.
this type of work and
Yes.
following the thought. So the question is, what is the size that people believe it becomes affordable as a tool?
Well, it depends. When we are talking about, even with small farmers, we have the minimum area that they are buying to do it. It's like 25 square kilometers.
25 square kilometers.
Yes. But we have big companies of agriculture,
No, of course.
and they have bigger areas,
Yeah.
really much bigger areas that they are acquiring, and extraction information.
It needs to be someone really huge to have access to this information.
Yes.
Affordability.
Yeah, so one comment I want to make about that is that, you know, the technology can scale up and down. If you're a small farmer and you have a small area, or if you're a big organization in agriculture, of course, there's different systems and different scenarios. But the importance here is that being in the agricultural sector, you want to reduce time and cost in sending people out in the field. You know, you don't want to have constant monitoring out in the field, because you can do that through a satellite or through a drone. You want to predict the yield of your crops. You know, how much yield you're going to get that year. So all of those types of information that you're trying to get through having people out in the field or through other kind of work that you do, you can do it through satellites. You can do it through drones. So of course, it's a cost benefit there, but as I said before, we have small systems that can work for small clients, or we have a big system that can work with Embrapa, for example, or a big ministry in a country.
There's no question for the big client, this is not a problem. I mean, the movement that we are, I suppose you are, as a company is doing right now, is to make it accessible to more, the smaller and smaller people.
Yeah.
They used it to be just for government and then
Yeah.
for the institutions.
Yeah.
But the movement is toward
Sure.
the small
Sure.
client.
Absolutely, I totally agree with you. And one example I can give you is that before, in the past, we didn't have drones. So for you to buy an image, it was $8,000 for one image, $10,000. Right now we have drones, so the smaller farmers, they cannot afford an image every month. They buy their own drone, $1,000, $2,000. They can fly the drone, get the images. So of course we're moving in that direction as well, to have technology, to have technology for everybody, not just for the big clients.
Now concerning Brumadinho, I saw some of the examples that you discussed, but can you tell me more, like, and I know you can do everything, just wanted to get more concrete details, like what type of environmental changes we can monitor and some more details in this change, because we think we brought some people from Stanford last week to visit the site. We went to visit the site and we expect to have changes in the environment for the next 10 years probably. So can you discuss some of this kind of changes that we can
Yeah. I went through a variety of different applications and examples in my presentation, both preventative and mitigation afterwards. So in the preventative side of things, for example, for Brumadinho, or for any other areas where there's a collapse, we can monitor the terrain. So we want to monitor that there's no movement or no changes on the terrain. So we can do that constantly, and we can have alerts that say, my terrain is at this elevation, 2,000 meters above sea level, for example, and it changed 1 meter or 2 meters or 1 centimeter. So we can be constantly targeting and looking at that. Of course, we can also look at changes, how the terrain or how everything is changing from one day to another. So for example, in the terms of a collapse or a mine disaster, we can see this is my area of interest, or this is my water here, and then the day after, the water is spreading out. So we can create alerts for that as well. If there's any changes in the terrain, we can create an alert for the authorities to have that information ready. After the event happens, which means, after the dam collapse in this example, one of the things we can do for emergency responders is to provide the information of what changed and how it's changed. So for example, we can take a look from an image before and after and run a change detection algorithm. Meaning the algorithm is going to detect any changes on the terrain after that event. So here, we're going to see, for example, we had 20 houses here, and now the houses are flooded because of the mudslide or because of whatever. So there's going to be people in those houses. We have roads that now are closed because of that disaster. So we won't be able to access that facility or that specific area. We can quantify the damages for insurance companies. So, like the roads are closed, 20 houses were lost, so that's going to cost the insurance company that much money. So there's a lot of things that you can do before and after the event. And in Brumadinho, we show a few examples of before and after. And of course, if that information was, and I don't have much knowledge of what the Brazilian government was doing or so on and so forth, but the importance is to be prepared for future events. Of course, we don't want anything happening in our countries, but it is critical for us to be prepared and for us to have that technology ready for whenever an event like that happens, we can address and we can, of course, be ready and go there soon enough.
Okay, and then concerning education, how can you discuss a little bit more with the type of partnerships and what kind of alliance that we can make? And so I'm asking as an institution.
Sure. Yeah, we are very focused on the academic sector. We have around 3,000 institutions around the world, and we like to collaborate a lot with the academia. Here in Brazil, we have some users of our technology, and we also, because of our interest in the academia, we develop what we call the education program. So we have a variety of courses and trainings for professors and students, teaching them how to use our technology, but also the theory behind it. So you want to teach the student or the professor, this is how you run the software to be able to create a map, looking at the changes, but this is the theory behind it. What is a pixel? What is a satellite? How is the signal from the satellite coming down to the earth and bouncing back to the satellite? So we teach all of that for free. It's material that we have on our website. We have videos, we have tutorials, we have courses, and the reason why we created that is because we want to have an active community of geospatial and of course the different tools that you can use to be able to extract the information from the sensors. So one thing that we're doing around the world is we are establishing centers of excellence, which means those are institutions that collaborate closely with us. And we create technology with them, we create scripts, we create workflows, or we create tools, but also we help them for them to diffuse our technology in that specific country. We have what we call Geomatics days. So for example, staff from our company come down, let's say, to Rio de Janeiro, and we have a whole day, doing presentations, showing the people what we can do, having trainings. So that's something, that's a very good question, and that's something that we work a lot, and something that we're passionate about, to be able to teach students. For example, we're going to be participating in the Canadian Symposium of Remote Sensing. It's a big symposium, a big conference in Canada every year, and what we're doing now is we are putting out a kind of like a prize for students that have created projects. We're going to get the students, we're going to fly them to the conference for free, we pay for their airfares and everything, and they're going to present the projects. So just to give you an example of the kind of collaboration and the kind of interest that we have in the academia, of course, for us to work with them and to collaborate and to give them our technology for them to learn and use that in projects like Geomatics.
I understood by visiting the site that you provide the students with a license where they can exploit the opportunities to use the tool. Could you tell us what are the space, what you open, and what's the limitation when you access this the software?
Well, talking about limitations that we have right now, we have the imagery from satellites that are commercial satellites, and in the past, for research institutions, it was
the limits for the students.
For the students, yeah. So the limitations, talking about the imagery, because you need the tools and you need the data. So before there were commercial satellites, so you need to pay to get data. Right now, there are satellites or organizations that give the data for free. So for example, NASA with the mission Landsat, the European Space Agency with the mission Sentinel, and now Canada will be launching satellites in the next few months, and they're going to be providing that data for free to anybody in the world that wants to download the data and use it for their projects, their thesis, or whatever. As we are working, as I said before, with a lot of different universities, and we provide the material, so it doesn't become a limitation. So the students, they don't need to, for example, go out of their way to learn how to use Geomatics or how to process an image. They have all that information ready, so nothing is a limitation anymore. You have the data for free, you can get the software from your university or from us, and you have the material to learn how to use the technology and how to be able to apply it to your project.
Professor Rossi, any questions that you'd like to do? I mean, you can do it in Portuguese if you feel comfortable, or in Spanish, you understand?
A princípio, a dúvida seria...
Mais alto.
Tá. A princípio, a nossa dúvida seria com relação a como a nossa engenharia de agrimensura poderia contribuir ou entrar na parceria junto com vocês no processo de aprendizagem para os nossos alunos, além daquilo que você acabou de citar. O que a gente poderia...
Ok. Se puder, existe uma licença temporária de avaliação e existe um programa que a gente pode assinar um acordo de entendimento para a utilização de um software para determinada ação por parte da ferramenta. O software incorpora dados de topografia também, seja de topografia, seja de pontos, né, que você pode estar utilizando o software, utilizando a imagem e acoplando esse tipo de dado para estudos também. Então tem essa possibilidade. Hoje a gente já tem um acordo de entendimento com a Universidade do Estado do Rio de Janeiro, nesse sentido. Eles são um centro de referência já da PCI, né? E a gente pode também, a gente tem procurado outras universidades para ter esse mesmo tipo de entendimento junto com a PCI. Então tem essa possibilidade, sim.
Nós temos um curso de pós-graduação de georreferenciamento de imóveis rurais lá na FAP, né? Às vezes a gente poderia trazer os coordenadores, bater o papo com os professores e levar essa tecnologia para o curso de pós. Talvez seja uma coisa interessante.
Perfeitamente. Um dos pontos que eu já havia até conversado com o Dr. Ricardo seria esse. A gente tem interesse, a Global Gel, como distribuidora da PCI aqui no Brasil, mas como provedora de serviço também. Eu tenho interesse nesse acordo de cooperação técnica, mesmo porque a gente tem interesse da empresa em estar contratando estagiários ou profissionais nessa área para prestação de serviço. Então, a gente pode verificar alguma forma da gente trabalhar nesse sentido.
Tá. A gente está com a questão que o Dr. Ricardo levantou, de Brumadinho, né, de como poderia ser utilizado lá. A gente tem já um projeto lá em Brumadinho, inclusive em parceria com a prefeitura, né, para poder fazer esse levantamento topográfico da região. Né? Então, eu acho que seria uma coisa interessante, né? A gente, às vezes, colocar uma tecnologia nova nesse processo, porque a gente já está mais ou menos autorizado.
Isso já é concreto, ok? Então, já é concreto que nós vamos ter acesso a PCI. O que nós estamos discutindo agora é assim, quais são as limitações, que tipo de data que eu posso dar, o que envolve dentro do acordo, que tipo de aluno que tem acesso, por quanto tempo, não é isso, Eduardo?
Exatamente.
Você quer falar um pouco sobre isso?
Preciso entender um pouco melhor como está o projeto, quais são as bases do projeto, qual é o objetivo final.
Para o estudante.
Para o
estudante. Quer dizer, o que é o seu padrão hoje?
O padrão, o regular qualquer pessoa que tem acesso ao site, qualquer estudante, ele tem direito à licença completa.
O fato de ele estar matriculado no curso, durante o curso você tem acesso?
Tem acesso à licença completa.
A faculdade só dá a relação dos alunos que estão matriculados?
Sim, seria um documento simples falando que está matriculado no curso, né? E a requisição através do próprio site da PCI ou através do e-mail para o Global. E a gente provê uma licença temporária de um mês.
De um mês.
No acordo de cooperação técnica, obviamente a gente vê isso daí num prazo muito maior e num número muito maior de pessoas também. E eu acredito que seria interessante vendo isso já para ter um departamento, um laboratório dentro da FEAMIG com a aplicação dessa ferramenta. É isso que a gente pode discutir dentro da
É isso que você tem que agora conversar de forma objetiva.
E aí eu vou precisar entender quantos alunos estão envolvidos nesse processo, qual é o tamanho da área, por quanto tempo, qual é o objetivo, isso tudo que a gente precisa estar discutindo em detalhes na reunião que eu tive.
Brumadinho tem essa formatação. Agora, você quer saber para o aluno, para você colocar isso no curso. Quando você põe a ferramenta disponível, você tem que garantir que aquela ferramenta continue durante pelo menos um determinado tempo do curso, não é isso?
Sim. Tem pacotes, tem preços especiais para laboratórios, com valores bem reduzidos, licenças definitivas, né? E aí são escalonáveis, 5, 10 assentos, 15 assentos, 30 assentos.
O que é importante agora é que esse assunto tem uma certa objetividade, senão o vocabulário passa e a gente não... Tá?
Como eu cheguei um pouquinho depois, eu fiquei na dúvida do seguinte, o seu software ele pega os dados satélite e faz o processamento dos dados satélite?
Satélite, fotografia aérea, dados de drones, qualquer tipo de
a fotogrametria faz o...
Sim.
Entendi.
Sim. Então eu posso... toda a parte de análise espacial, desde geração de modelo, a partir do levantamento aerofotogramétrico que tem estereoscopia, ou a coleta de pontos, uma nuvem de pontos de contatos com GPS, com RTK, para gerar um modelo, isso também pode ser feito através do software. Tanto a extração de informação, conforme ele falou, você vai ter uma imagem antes do acidente, uma imagem depois do acidente, e eu vou poder estar quantificando qual foi a área que foi atingida, como que a vegetação, por exemplo, está se comportando após o acidente, se está tendo problema com desfoliar ou não, coisas do tipo.
Entendi. A questão é a seguinte, eu vou separar uma questão prática aqui. Nós temos duas situações diferentes. Uma seria de utilização do software numa situação prática, por exemplo, no caso não só de Brumadinho, mas de uma ferramenta da Lagoa da Petrobras. Nós estamos com um convênio com a prefeitura de Visita para poder fazer isso. Porque o professor, nós já separamos alguns alunos que vão acompanhar esse processo de mapeamento da lagoa. Isso é uma questão prática. A outra questão é a aula. No caso da aula, né, qual é a principal diferença entre o produto que vocês vendem e aquilo que já existe no mercado?
PCI é um software completo. Então hoje você tem mais, que mais é utilizado no Brasil. Você tem um software de SIG, que é o ArcGIS. Você tem um software topográfico, um TopoCAD, ou algo um AutoCAD, MED, ou alguma coisa do tipo. O PCI ele engloba todas essas ferramentas dentro dele. Então ele tem toda a parte de análise espacial com si, como tem toda a parte de tratamento de informação vetorial, como no AutoCAD, como que é o forte mais dele, que é o tratamento da informação raster, de imagem mesmo para geração de dados, de análise espacial e até a produção de mapas.
O meu aluno saindo da escola hoje, ele vai encontrar o seu software nessas principais empresas grandes?
Sim, hoje vocês têm principalmente órgãos governamentais, né? A gente tem o INPE, um usuário nosso, o IBGE é um usuário nosso, CPRM tem licença, Visiona, Embrapa, a gente tem compensação, tem uma série de clientes aí que utilizam o software. Instituto Tecnológico Vale, por exemplo, uma série de clientes que são empresas que são
uma forma interessante de vocês entrarem lá na escola seria através de curso de extensão, de cara. A gente criaria aqueles cursos de prazo para o cara aprender a mexer com aquilo.
Eu tenho muito interesse. Um dos fatores que a gente obviamente tem esse projeto de Geomatics, mas o interesse maior seria capacitar a minha amiga para a gente.
Com os cursos de extensão, porque o curso de extensão leva o aluno, ele faz o curso de extensão, básico de operacionalização, conhecer a ferramenta. E aí ele acaba sendo um replicador desse processo, porque aqui a escola de agrimensura mais próxima da nossa está em Viçosa. Então, assim, essa região metropolitana toda de Belo Horizonte só tem uma escola que é a nossa.
Por parte da Global Gel, tem um interesse específico nisso daí, porque a gente, como eu falei, eu pretendo estar contratando topógrafos, engenheiros de agrimensores, para estar fazendo parte do corpo da Global Gel para determinados projetos. Então, a gente vinha muito só na questão de tratamento espacial, mas não com essa coleta de dados em campo propriamente dita. Eu preciso disso daí também. Então, tem interesse a gente formatar um acordo de cooperação técnica que envolve essa possibilidade, envolvendo software para a universidade desse forma, e a capacitação técnica, e a contratação dos estagiários,